Hello, my name is Peter Wittenberg. For many years, I was leading the technology work at the Max Planck Institute for Psycholinguistics, where we did data-driven science to understand how human brains are processing speech and language. Since we often worked with statistical models from early on, we needed much data and got into the business of data management and European data infrastructure building. Since we urgently needed increased interoperability, as you can guess, we later founded the Research Data Alliance, and in 2021, we founded the Fair Digital Objects Forum to accelerate the work on a generic and minimal data representation standard called Fair Digital Objects. In this video, I will not explain the basics of the Fair Digital Objects. You can find that in other videos and in the documentation, but focus on the relation between FDOs and the many data spaces which are currently under development worldwide. For us, it seems to be clear that these two concepts, fair digital objects and data spaces, will be crucial for the distributed digital era we are starting to build right now. Why do we need to speak about two technologies? As you may know, basic FDOs encapsulate rights specifications as all kinds of metadata about the included bit sequence, but are basically passive units. That means they do not interpret the rights assertions to turn them into actions. This is exactly the purpose of Dataspace technologies. They are built to interpret rights assertions and control data reuse within data federations. In this video, I will explain this relationship. Let me start with saying that, in my opinion, we are still used to manage and exchange individual data items instead of looking at data as objects, which bundle the bit sequence and all relevant metadata as indicated in the two diagrams. Data and different kinds of metadata are managed by different systems and exchanged as separate files or data items. Then software is being used to bring these items in relationship, which is creating lots of reuse problems, and which, in my view, is not adequate anymore in the evolving digital era. Instead, users should look at data objects, which include all relevant information to allow further processing. This could even mean to include operations in the object, which, for example, can ensure high security and controlled reuse and could be extended to autonomously acting agents. Let me just add for clarification that fair digital objects and digital objects are almost identical concepts. Fair digital objects must be machine actionable by adhering to some metadata standards. Digital objects, or if you want, fair digital objects, are not at all new. The international publishers implemented the well-known digital object identifier concept and the big film industry the IDER concept already decades ago with great success. Many others in industry and science also applied the digital object concept. In fact, cloud systems are also based on the digital concept, since comprehensive metadata is stored in fast memory to give ultra-fast access to all information of the data object. Independent of how individual repositories organize their data, the turn to FDOs will allow us to use one interface protocol to all data out there. Repositories will have to implement a digital object server to hide their implementation details to the outside world, which is a doable effort, as we have shown. As indicated in the diagram below, we could currently see many serious activities in several countries to design and implement Dataspace technologies that interpret rights assertions formulated, for example, in open digital rights language, and thus implement policies to enable controlled reuse of data. Different approaches are being tested with much effort, resulting in the usual lack of interoperability. I will try to explain in a few words that FDOs can play the role of a common basic lingua franca for all these developments, as indicated in the below diagram. Also, here we can refer to concrete projects where we have demonstrated how FDOs can help to bridge between data spaces of different nature. Let me first have a somewhat deeper look at the term data space and the current development flavors. A data space is a federation with a focus on data where partners agree on a set of rules and technologies to share and reuse data. However, I should add here that there are specific data space technology developments which were inspired by the early data space reference architecture as described by the German Fraunhofer Society. This was implemented in projects such as the German Mobility Data Space, for example. Two more recent flavors were developed by the International Dataspace Association Architecture Working Group and within the Factory X project, which has the task to develop common data space technologies for several vertical data space projects such as Catena X, in which the big car building system companies are engaged in, for example. But we also see major developments inspired by this early IDSA reference architecture in Japan and China, and much interest in other regions such as Africa and Australia. In Japan, we can, for example, refer to the DSA and Uranus initiatives. But there's much more out there, of course, when we speak about relevant data, which we would like to share and reuse. Let me, as an example, just refer to about 50 European ESRI projects, which were all focusing on building data infrastructures for the benefit of data-driven science, as indicated on the right side. They started work in 2009 and built partly extremely successful data federations where many partners throughout Europe and even beyond agreed on some rules and technologies, for example, to build joint catalogs and now also to integrate data to smaller and larger domain models. Similar projects were implemented in many different countries and regions worldwide. What I want to express with this slide is that there are many different approaches to implement data spaces, all using different rule sets and technologies. The big question for us is now whether there is a common core which is independent of the different legal systems the partners are in and independent of the type of repositories and data systems they are using. This question is almost identical on the one Bob Kahn and colleagues were facing when they started the TCP/IP and Internet work some decades ago. We believe that the answer is yes, there is a common core, but let me first dig a bit deeper into data space technologies. As FDO Forum, we organized extensive interactions with the former IDSA Architecture Working Group chair from Microsoft and leading experts from the important Factory X projects. In the two architectural diagrams shown here, which at first glance look very different, one can identify three major levels that need to be addressed. First, there needs to be trust building with the help of formal contracts across companies which are operating in different legal contexts. Second, when contracts have been signed to create a data space, formal data access rules will be defined and interpreted between the partners. Third, when the negotiation phase between providers, defining criteria and policies, and consumers, indicating goals and credentials, was successful, tokens are being generated that allow the consumers to access data and metadata. Since different trustworthy identity providers can be engaged, and since the application of software is not as restricted as in the first IDSA model, these new architectures are much more flexible. In this video, I will not go into the further detail of these architectures and leave it to you to study the documents from IDSA and Factory X, and there's a more detailed comparison from us. You see the link below. On the next slide, we expect that these three levels, on this slide, we expect that these three levels, which seem to be data space technology universals. As said, There must be a trust framework based on formal contracts. In the control plane, the negotiation about access permissions will happen. And finally, in the so-called data plane, the actual data and metadata will be exchanged. I should mention here that there are some standardization activities ongoing around these three layers. When looking now how FDOs could fit into this dataspace role, we can see the following. FDOs bundle all relevant metadata information, including the rights specifications, and this can be done in a highly secure manner. One simply needs one persistent identifier to access the whole bundle. The rights information included in the FDO can be used to negotiate the terms of access in the control plane. The FDO then would make it easy to access all information which is necessary to process the bit sequence, which can be of any type. What is now the advantage of using FDOs in this game? The Dataspace technology can simply make use of one single protocol to access all data and metadata independent of all the differences of the repositories and dataspace systems. The responsibility is shifted to the repositories to provide an FDO server, which is not so difficult to develop. Another advantage is that rights information is burned into the object. That means by encapsulation, it is available independent of the context, and it cannot be changed by unauthorized actors. Is this all new? No. In the FDO1 project, we showed that FDOs can indeed provide all information to bridge between different dataspace systems and to include a variety of different repository systems as indicated in the diagram. In the FDO1 project, we integrated the mobility dataspace, bottom right, a dataspace defined by Industry 4.0's asset administration shell model, and 4 different repository types, including the S3 object store. To realize this project and to demonstrate operation, we only needed 88 months, including the various adapters to be built and the development of a first FDO manager. Let me come to the conclusions. The situation resembles the situation a few decades ago when computer networking was the big challenge and when different networks were already existing. TCP/IP unified the basic interaction layer, could relatively easily be implemented by everyone and was pre-competitive. The ISO-OSI model helped in understanding networking, but was much too complex to be implemented successfully and included levels where companies were competing. The FDOs can operate in all circumstances, from open science to contract-based dataspaces, which implement control, reuse, and therefore data sovereignty. FDOs ensure that the major properties of the data, including the rights, remain the same independent of the context and technologies used. FDOs bundle and encapsulate not only the data, but also all relevant information about the data in a persistent and secure way. That means they can be used outside of and within different data spaces depending on the needs. This all makes the FDOs an ideal basis to manage and use, for example, the huge number of AI models, model versions, their training and test sets, which will populate the distributed digital era. We hope that this video gives already some first information about the relation between FDOs and dataspaces and dataspace technologies. The FDO Forum will continue to interact with the dataspace technology developers in the various regions to offer the FDOs as a basic layer of interoperability, which is comparatively easy to implement. I should mention that the next FDO conference in March in Wien will have this relationship as one of its major topics. Slides and videos are available via the FDO website under videos and slides. Thanks a lot for your attention.